recording this for those who can't be here right now but can view it later. Okay, so the question I am looking at right now says find the standard equation of a circle. And I know you can't see this right now, but we're given that the center is a particular ordered pair and the radius is, I'll write those down here. The center in my particular problem is at 3, 7. I think it was 3, -7. And the radius of my particular problem is 1/3. So that's the problem I've been given, and I'm asked to find the equation of the circle having that center and radius. And so we can go back to the basic equation of a circle, which is x minus h quantity squared plus y minus k quantity squared equals r squared. Well, our radius is the r. The center is always hk. And so now that they've given us the center, so they've given us the h, they've given us the k, they've given us the radius, so we could just plug those into our formula here. So I've got x minus the h, which is the 3, squared plus y minus the k, and k is -7, and that's squared, equals the r, which is 1/3, and that is squared. So x minus 3, I can leave it. You'll see what they gave us was a multiple choice answer, and they want the full equation. So there's nothing I need to do here. I can just leave that x minus 3 quantity squared. Y minus a -7, and minus a negative becomes plus. So this becomes y plus 7 quantity squared. And 1/3 squared, well, that's the same as 1/3 times 1/3. So we would multiply the numerators together and multiply the denominators together. And that would be the equation of the circle that fits that center and radius. If I need to graph that, I could come over here, and the center was 3, -7, so I come over 3 down 7, and that's the center. Oh, I need to drop that. So 3, -7 is right here. The radius was 1/3, so this is going to be a tiny little circle, but I can start there and drag out 1/3. Let's see, why is that not dragging? Drag out 1/3, and there's my circle. It's tiny because the radius was so small. But that would be the circle that fits this particular equation. So if the radius had been not 1/3, let me just kind of, oh, I didn't want that tool. I'll cross that out. Instead of 1/3, say it was 3. Now instead of 1/3 here, we would replace that with 3, and 3 squared is 9. So now my circle would start in the same spot, but it has a radius of 3. And the best way to get that is to drag perfectly horizontally if you can, and go over 3, and there's that larger circle. So we can see that we can get these fairly easily and get those graphed, but it's important that we know this. Oh, once again, I've got my circle tool on. That we know that equation. Once you know that equation, then you can, it's a matter of just plugging stuff in. So let me get rid of all of that work. Oh, that's funny. I had it on the wrong layer. So if I had, say, this equation, x squared plus y squared equals 25, and I needed to graph that, so I think I can bring another one of these up. So if I'm graphing this particular equation, recall that our standard equation was x minus h squared plus y minus k squared equals r squared. So going back to what I've got here, I don't have anything subtracted from x, so I could write the way we denote nothing is our 0. I don't have anything subtracted from y, so that's like y minus 0. And 25 is 5 squared. So now I see what h is, I see k, and I have r. So the center is hk, so 0, 0. So the center is right here. And there we go. So come back to my circle tool. Got a radius of 5. So start there and drag out until I have a radius of 5. And there's the circle of that matches the x squared plus y squared equals 25. So once again, key is recognizing our standard equation for a circle. Now I think the first one they gave us was just x squared plus y squared equals r squared, which will be the case if the center is at the origin. But as soon as you move away from the origin, we need that h and k, and so that's why I concentrate on that full equation. But hopefully that helps clarify a little bit about how those circles work.
Yeah, that helps me. I guess what my confusion was is the first equation that I did had the whole thing, the x minus h and the y minus k. But then when I came to the x squared minus plus y squared, that threw me off for a bit. And that's why it took me so long to recognize what I was looking at. And finally, when I figured it out, it made sense. So.
And you know, there's a lot of power in figuring that out. We're less likely to forget it, I think, because of all the hassle we went through to remember it.
Yeah.
But it can help a lot to see it worked out kind of this way. All right, were there any other questions that anybody struggled with? Chris, you've joined us. How are you doing?
I'm doing okay.
Good. Honoria, did you have any questions?
I'm having a hard time figuring out how you get the numbers from.
I'm really struggling to hear what you're saying. It might be better if you just typed it into the chat. Is that something you can do? Do you have a keyboard? I don't know if you're on your phone or something. I was typing in the blog today, typing in a bunch of the stuff that we're working with this chapter. And so I remember a little bit of what we're dealing with, but I can grab a problem here from section 1.2, say, if we don't have particular questions. There's a number 5 on 1.1. How do we get numbers to plot? That's a really good question. So let me go back to 1.1. I'll pull up question 5. Question 5 for me is y equals 1/4 x plus 9. So let me grab a new layer here. Okay, so the question I had was y equals 1/4 x plus 9. And the question that was asked is, how do I get points to graph? And we've got a couple of different options here. I'll start with the way that will work with any function that you're asked to graph, and that's to create an XY table. This will always work. This will always give you points that would fit on the graph. And so because we've got y equals a bunch of stuff happening to x, x becomes our independent variable. And so we would pick values for x and plug those in and see what we get. Now the points I usually pick to plug in are -2, -1, 0, 1, and 2. And I do that because it gives me 5 points. They straddle the y-axis, which is what happens when x equals 0, and I can usually plug those in and get some good values. I don't think that will help me quite as much with this particular problem, and the reason that I believe that is because just looking ahead, if I plug -2 in for x, -2 times 1/4 is -1/2, and MyMathLab doesn't often like me to graph fractions. So I'm going to instead pick values that when I multiply them by 1/4 will give me an integer. So if I say start with -4, and I'm going to go ahead and do 0, and I'm going to do +4 as well. Now, as I said, this method will work with any graph we've got. So no matter what the function is, we could pick x values, plug those in, and see what we get for the y value. So I'm going to plug -4 in for x and see what I get. So I've got 1/4 times -4 plus 9. So 1/4 of -4, if I multiply those two together, I get -1 plus 9 is 8. If I plug in 0, 1/4 times 0 plus 9. 1/4 times 0 is 0, plus 9 is 9. So I'm creating ordered pairs here. Now I'll plug in the +4. 1/4 of 4 plus 9. So 1/4 of 4 is 1, plus 9 is 10. So the ordered pairs I've created are my x value and the corresponding y value I got after doing the calculations. So I now have 3 points that are part of this function when it's graphed. And so now I can just come over here and I can plot those points. -4, 8 is there, 0, 9 is here, and 4, 10 is up here. And so now all I need to do is connect the dots, basically. And I would, of course, extend that out and put arrows on either end to show that it keeps going forever. But that would be the function of this particular, if we graph y equals 1/4 x plus 9, we get that particular graph. That's going to work all over the place. If I had, let's say, the function y equals x squared minus 9, I can do the same thing. I could create an xy table, plug in values for x, and see what the corresponding y is. And that's going to work. It'll work great. But just wanted to point out that we've got this option for us. Create an xy table. Now another thing that we can do, and I'm trying to remember which section we cover. I know we cover it in this week. And that's to recognize that this particular function is written in the form y equals mx plus b, which is, this is covered in chapter 1. I don't know that it's covered in section 1.1, but it is covered in chapter 1, so you'll get to it this week. In this form, m is the slope, and b is the y-intercept. So b in this equation is where the graph will cross the y-axis. And notice with the points we picked, and when we graphed it, sure enough, it crossed the y-axis right here at 9. That's what, in our equation here, we've got b is 9. So that works out just fine. And then we've got slope here. Slope would be this coefficient to the x, because that's where m is. And so now our slope here is 1/4. So let's talk a little bit about slope. And this may be looking forward to, say, section 1.3 or something. Slope, when we think about hitting the slopes and so on, we think about hills. We think about going up or going down some hill. And we measure slope as how far you either rise or drop versus how far you go forward. And so we will often think of slope in terms of rise over run, where rise is how much it goes up and down. Notice up and down, that's dealing with our y-axis. And run is how much it goes left and right, or how forward or backward you would go if it were talking about your movement. But left and right is the x-axis. So we're looking at a change in the y over the change in the x. So our slope on this particular problem is 1/4. So we rise 1 and run 4. So again, if I come back to my equation, I could start here at 9. I could rise 1 and then run 4. And it puts me right there at that particular point. And so I've risen 1, run 4, and then I just connect those two dots. That's another way you can get points to graph. And that works with a line. Line is the only function we're going to deal with that has slope of the entire graph. And so you can think of it in terms of rise over run as a way to get the second point. Once you plot the y-intercept, you can use the slope from that point, from that y-intercept, to get a second point. Now, I'd also like to point out that rather than rise 1 and run 4 to the right, we could have dropped 1 and run 4 to the left. Because a negative rise and a negative run, recall negative divided by negative is a positive, that would get us to another point that is also on the line. So those are a couple of different ways that we can get points to graph a line. Let me do the same thing. Now this is a different problem. This is from section 1.2 actually. But I'm going to do the same sort of concept, only with that other function I was talking about. Y equals x squared minus 9. Now this is not a line. And you will know that by the end of the semester. Just by looking at it, we can see it's not a line. You may not have been exposed to that yet, but you will be. When you have both y and x in a function, and one of them has an exponent, it's no longer a line. This one happens to be a parabola. And we know that because the exponent is a 2. But let's go ahead and create this xy table. I'll go ahead and pick those initial values that I mentioned I like using. They're also pretty easy to do in our head, generally speaking. 2s, 1s, and 0s, we can multiply lots of those together. So now I'm going to square the negative 2 and subtract 9 from it. Negative 2 times negative 2 is a positive 4. Minus 9 is a negative 5. I'm going to square negative 1 and subtract 9 from that. Negative 1 times negative 1 is a positive 1. Minus 9 is negative 8. And we'll plug in the 0. 0 squared is 0. Minus 9 is negative 9. 1 squared is 1. Minus 9 is negative 8. And 2 squared minus 9. 2 squared is 4, minus 9 is negative 5. So I've created 5 ordered pairs. Negative 2, negative 5. Negative 1, negative 8. 0, negative 9. And by the end of this class, you'll be able to look at that and know exactly what the graph is. You won't even think too much about it, which is kind of nice. But here at the start, what we're showing is that we can use this XY table to graph things we're unfamiliar with. So now I've got this ordered pair. Now I do want to caution you where I'm squaring these negatives. If you're using your calculator and you just type negative 2 squared, that is not the same as negative 2 quantity squared. Because our order of operations, our PEMDAS, we've got parentheses, exponents, then multiply, divide. This one on the left-hand side, exponents, so the 2 squared will happen before multiplying by a negative 1. Negative 2 squared is negative 4. But negative 2 quantity squared, or negative 2 times negative 2 is a positive 4. Those are not equal. So be careful with your calculator. If you're squaring a negative, go ahead and put it in parentheses just to force the calculator to do what you know needs to be done. Be careful with that one. I've seen a lot of students just plug this one into their calculator and it gives them that value when what we want is this value over here. So just be real careful. All right, so now I can go ahead and plot these points We've got -2, -5 is right here. -1, -8 is down here. 0, -9. 1, -8, and 2, -5. So you can see this is clearly not a line. But we can plot those, we can graph them, and it's a parabola that opens up that crosses the y-axis at -9. So you can see the XY table works really well. It gave us those ordered pairs, and we could go ahead and plot those. Once again, later you'll get real familiar with graphing these with an x squared. But for now, just know that we can graph pretty much anything we want using an XY table. I think it's a powerful way to find points to plot things. So in homework 1.2, when you're asked to plot a function similar to this one, this would be a good way to do that. You'll not use the line tool in MyMathLab. You'll use what they call the quadratic tool. It gives you this parabola. And they want 3 points. So you'd only need 3 of these 5 to actually plot the parabola. But it should work just fine. Okay. Something else I'd like to mention since we're here, and that would be the y-intercept. On this particular problem, the y-intercept, the place it crosses the y-axis, is down here at -9. Notice that a y-intercept, a place it crosses the y-axis, all along there, every single point along the axis has an x value of 0. And so if we let x equal 0, we get the y-intercept. If we let y equal 0, so y equals 0 here, and all along that x-axis, we have a y equal to 0. So if we let y equal 0, we get the x-intercept. Now notice that there are some spots in the homework that ask you to plot using the intercepts. You can have the right line, but if you don't use the intercepts, it will mark you wrong. So that's one of those finicky things. Watch that blue text around the answers to make sure you're doing it right. And if they ask you to use the intercepts, you need to follow this procedure right here. Let x equal 0 to find the y-intercept, let y equal 0 to find the x-intercept, and that will allow you to plot it. So with this initial problem we had here, if we set x equal to 0, which we did right there, we got the y-intercept. And I know it's not a line, but it still intercepts the y-axis at the point 0, -9. And so we can still look at intercepts. We can look at the x-intercept. If we set y equal to 0 here, and I'll go ahead and do that. So we've got 0 equals x squared minus 9. I would add 9 to both sides. And I've got 9 equals x squared. Well, I want just x. So what I'm going to do is I'm going to go ahead and take the square root of both sides. And the square root of x squared is just x. The square root of 9 is either plus or minus 3. -3 times -3 is a positive 9. +3 times +3 is a positive 9. So my x-intercepts are plus or minus 3. So this particular graph is going to cross the x-axis right there and right there. Oh, come on. So if I extend my graph up, it's going to go right through those points. So you can find those intercepts, and sometimes those can be really helpful. So if you haven't done 1.2 or haven't looked at some of these other graphs or are a little unsure about how to graph, you can take this to heart. Hopefully this will help make those easier for now. So I know, Honoria, you asked a simple question and you got a long drawn out answer, but hopefully that will help beyond just the one you asked about. Oh, good. I'm glad that helps. Are there any other questions that any of you have? Now you're probably scared to ask because of how long my answers are. Kind of looking at homework as well to see if there are other problems maybe. Or I'm even looking into 1.2 or 1.3 to see if there are things I can work on. Maybe, oh, this is a good one. I'm going to do a snippet of this one and just copy it over because I want you to see the whole thing. We'll talk about it. I don't need those. All right. So looking at this particular problem, they've given us a graph and we can see that it looks like a parabola. So this is probably an x squared. Actually, I know it is, but we'll get to how to find all of those later. Now they ask us to find this h of 2, h of 4, and h of 5. Now that notation is kind of interesting. Notice they've got this h of x, so we've got some function, and it would say something like h of x equals negative, oh, let's say x minus 4 quantity squared plus 7. Might be a function like that. And this function would match that graph. So when they say h of 2, notice that what we've done is we replaced x with 2. So I can do the same thing over here, just replace x with 2, and mathematically calculate what that is. But I don't have to do that if I have the graph. With the graph, I can just say, okay, they replaced x with 2, so I'm going to come over to an x of 2, and I will rise or lower until I get to the graph and it's right there. And then I can come over and read what that is, and it looks like that's 3. So h of 2 is 3. I just read it right off the graph. H of 4, I'll go ahead and change colors here, come over to an x of 4, and go up until I get to the graph, and then come across and read the y value there, and that looks like 7. So h of 4 would have a value of 7. So I can just read it right off the graph that way. H of 5, grab a different color. H of 5, I come over to 5 and go up until I get to the graph. It's right there. Come across and read the y value, which is a 6. So h of 5 would be 6. Now, again, say I have the function here, and I plugged in my value. We'd have our negative. 2 minus 4 is negative 2. Square that plus 7. Negative 2 squared is 4, but I've got this negative out in front, plus 7, and negative 4 plus 7 is 3. So h of 2 would be 3, and sure enough, that's what we got when we read it right off the graph. I do not expect you at this point in the game to be able to create this equation from the graph. I really don't. I just wanted to show you that we can either graphically get it or mathematically get it if we have the function. By the end of the semester, you'll be able to create this function. Today, I don't expect you to. Not at all. This is chapter 10 stuff. So don't worry about it today. But graphically, you can get the answers just like we did here. Algebraically, we can if we have the function. And so a couple of different ways to get our same result. For this particular problem, and this is problem 9 on section 1.2, you just move over to the appropriate x value, go up or down until you get to the graph and read the corresponding y. That's all you need to do in this section. So that can be, I mean, it's kind of a fun way to read it, and it can be a weird graph. That they give us another one here. Let me show you this one. This one I'm not even going to try to get the function for, because we can do it. It would just take some extra time that we don't need to worry about right now. So let me show you this one. Like I say, I'm not going to try to find the equation that goes with this, but we need f of negative 3. So I come over to negative 3, which is here, up until I get to the graph, come across and read the y value. That looks like it's a 1. So f of negative 3 is 1. F of negative 2, I come over to negative 2 on the x, go up or down until I get to the graph, come across to the y value. That looks like a 5. And then we've got f of negative 1. I come over to negative 1 on the x, up or down until I get to the graph, and come over to the y-axis and read off that value, and it tells me the function. So really, it's way easier even than doing it algebraically. You just read it right off the graph. That can be preferable. A little more enjoyable. It's quicker than plugging it into the function. No, clearly plugging it into the function works as well. All right, I have talked a ton. Do you have any questions?
I don't have any questions right now.
Okay.
I think I'm good.
Excellent. All right, well, we're 5 minutes early, but I feel like I've talked us a bit into the ground. We're still early on, but go ahead and keep working on the homework. Let me go ahead. I think I don't have Chris marked here yet. Okay, now I've got Chris marked here. Keep working. When you've got questions, bring them in here. I still plan on working other problems. If you don't have questions, make sure we can understand this stuff fairly well. Is this working for you? Me working here in Photoshop and showing you problems?
Yeah, that helps me.
I think so.
Excellent. I like this. I've got a graphics tablet, so it's like I'm writing with a pen. Good. Helps Honoria as well. So I think this, generally speaking, will work, and I'll just keep this going. And I can view your individual homework. So if you say I'm having a problem with question 5, I could go in and see exactly what your question 5 looks like, and pull it in just like I did these. And so as we're working through these, we can look at exact problems and come together to better understand all of this. I think working in a group always helps. So I'll plan on keep doing this. All right. Well, let's call it a day. I will let you enjoy your day. It seems to be a nice one. So hopefully you're able to get out and enjoy the weather a bit.
Thank you.
You're welcome.
Thank you.
Have a good night.
You too.